We are going to quickly go through a brief description of the quadratic formula, and we will also go through some examples of right triangles and how the quadratic formula can be used to find sides of the right triangles. The quadratic formula is a convenient way to determine the solutions of a quadratic equation that is in standard form. So, what is standard form? Standard form is when we have a quadratic equation in the form ax squared plus bx plus c equals 0. So, if we want to determine the solutions of this quadratic equation, now we have several other methods that we could use, but we're not going to discuss that in this particular video. We could factor, we could complete the square, but here we are actually going to apply the quadratic formula, which is x equals negative plus or minus the square root of b squared minus 4ac, all divided by 2a. The last topic for this video that we're going to cover will be right triangles. So a right triangle, you should remember, has two legs, a right angle, and then of course the side across from the right angle is called the hypotenuse. So we call this leg 1 or a leg. Now so A is a leg, and then I'll name this side B, and this is also another leg, and then this is the hypotenuse or side C. So just like the quadratic formula that we talked about, we have a way. The quadratic formula was used to find the solutions for a quadratic. We have a way of finding a missing side for a right triangle, and we call that the Pythagorean theorem. So the Pythagorean theorem is simply the hypotenuse squared, c squared, set equal to the sum of the squares of each leg. So I have a squared plus b squared. Now let's apply this. For the first example, I have 8 as one of the legs and 4 as the other leg, and I want to determine what the hypotenuse is. So I use the Pythagorean theorem, which was x squared set equal to the sum of the squares, 8 squared plus 4 squared. This is where knowing the squares of numbers is very important. 8 squared is 64, 4 squared 16. The sum of the two numbers gives me 80 equals x squared. In order to determine what x is, since I have a square, the only way to undo a square is to take the square root. Well, whatever you do to one side, you must do to the other, which leaves me with x is approximately 8.9. Let's look at another example. Let's say we have 2.7 for this leg. This time we know the hypotenuse, but we want to find the remaining leg. Formula again is the hypotenuse squared, which is 7 squared, set equal to the sum of squares of the other legs. So that gives me 2.7 squared plus x squared. 7 squared is 49. 2.7 squared is 7.29 plus x squared. This time I'm actually going to have to solve an equation, so I subtract 7.29 from both sides, which leaves me with x squared equals 41.71. Again, I want to solve for x. I take the square root of both sides, which leaves me with x is approximately 6.5. For the last example, we are going to couple the quadratic formula and the Pythagorean theorem so that we're able to solve a word problem involving a right triangle. So we have a carpenter is building the frame of a bookshelf that has the form of a right triangle. The base of the triangle is 7 feet greater than the height, and the hypotenuse is twice the height increased by 3. What are the dimensions of the bookshelf? So this seems like a lot going on, but not really. Let's just see what's happening. And maybe the easiest way to start is to draw a picture. So we are going to draw a right triangle. And again, this is a bookshelf, but we can just draw a little right triangle to mimic what is happening in the carpenter's factory. Okay, so it states that the base of the triangle, base is here, is 7 feet greater. So greater, we know that we're going to be adding 7 to something, the height. So the height is here, and I'm going to go ahead and label the height as x. So that means that the base is x plus 7. Next, we're told that the hypotenuse is twice the height. The height is x, so twice the height, 2x, increased by 3. So that will be plus 3. Now we have a right triangle, and we have labels for each of the sides of the right triangle. Now, applying the Pythagorean theorem, we have the hypotenuse squared, so the quantity of 2x plus 3 squared equals each of the legs, the sum of each leg squared. So we have x squared plus the quantity of x plus 7 all squared. So now you should remember, some teachers teach FOIL, but it's just multiplying two binomials. So that would, the quantity of 2x plus 3 squared is simply 2x plus 3 times 2x plus 3, which gives us 4x squared plus 12x plus 9. On the right side of the equation, we still have the x squared. Now we have the quantity of x plus 7 squared, which is simply x plus 7 times x plus 7, or x squared plus 14x plus 49. So now we're going to collect like terms. We have 4x squared over here plus 12x plus 9. 2x squareds are here, so that is 2x squared plus 14x plus 49. Now you notice that we have all of these different terms, and we have x included, and we have an x squared, so that means that ultimately we should be able to get this into quadratic form, or standard quadratic form. So we're going to subtract 2x squared to the left, which gives us 2x squared. And I'm going to go step by step just so that I don't lose you along the way. Then I have the plus 2x plus 9 equals 14x plus 49. Then I'm going to subtract 14x to the left, but whatever you do to one side, you must also do to the other. That leaves me with 2x squared minus 2x plus 9 equals 49. Last step to get it into standard form is to subtract 49 from both sides, which leaves me with 2x squared minus 2x minus 40 equals 0. So I could immediately apply the quadratic formula, but instead of doing that, you should see that each of the terms are divisible by 2. So I'm going to divide each term by 2 to give me x squared minus x minus 20 equals 0. Now remember again, We could use factoring to solve, but I just want to show the quadratic formula with this application. So that gives me a negative b, or negative times negative 1, plus or minus the square root of the quantity of negative 1 squared minus 4ac 1 times negative 20, all divided by 2a, which is simply 2 here. So I have 1 plus or minus the square root of 1 plus 80 divided by 2, which is 1 plus or minus the square root of 81 divided by 2. The square root of 81 is simply 9. So you know that there's no such thing as a negative measurement, so I can actually throw away the second. Instead of ever working out 1 minus 9, I can just do the 1 plus 9 divided by 2, which is 10 divided by 2, which is 5. So the measurement for, or the dimension for this bookshelf is, so x we have as 5, x equals 5. The hypotenuse was 2 times x, which is 5, plus 3, which gives me 13. And then the other leg was x plus 5, which is simply 5 plus 7, which is 12. So we have 5 by 13 by 12.